Alright, in this video we're going to concentrate on developing MATLAB code to modulate a speech signal. So along the way we're going to find out, first of all, to give us some headroom for modulation, we're going to need to resample the signal. I'll talk about that a little bit. And then we can view resampling as a black box. There's a really simple MATLAB command that lets you resample a signal to a different sampling rate. We'll talk about how you would choose the parameters for that. Then, once we have our new sampling rate, we would then need to generate an oscillator or a sinusoid in MATLAB, and from there, that would let us modulate. Okay, so let's go back. We had talked about, in a previous video, sampling a speech file and then loading it in MATLAB and playing it back. Okay, the speech file we had looked at had a bandwidth of 4 kilohertz, and if I wanted to modulate that out to a different frequency, the sampling rate is 8,000. There's no room to move it, right? All digital signals, if you have a sampling rate of 8,000, the maximum frequency that can be represented is 4,000. So we need some room, all right? So if we resampled that signal, effectively what we would get is changing where the replicas show up, all right? So if we take our first replica, or 0th replica, all right, here it is. We put that here. It has 4K, all right? And then if we move it out to FS, we could give ourselves a lot of headroom by moving FS pretty far out, okay? So we need to have a plan. Let's say we wanted to form a signal, a modulated signal, where let's see, S of t, the signal we're trying to form, is y of t times cosine 2 pi fct. We can't make fc too high because it would generate so much data if we had too high. If we were doing in the kilohertz or thousands of kilohertz range, that would be a problem. But we could make some fc something like 30,000 kilohertz. All right. So if we did that, what would the bandwidth of the modulated signal look like? Well, we know you'd take the 4K and you'd move it up to 30K and minus 30K, and you'd have our signal showing up here and here, and that would put the upper edge being at 34K. All right, so we know our sampling rate would have to be at least 34 times 2, okay, at least 68K. All right? So it turns out MATLAB has a resample function. And what you do is you put the signal in that you want to resample, in our case it would be Y, and then you put a P and a Q. P is the upsample factor. Q is the downsample factor. So, if you wanted to change the sampling rate, so you started with 8,000, you'd multiply by P and you'd divide by Q. So if you made, for example, P equal 3 and Q equal 2, you would have 8,000 times 3 divided by 2, and you'd have a new sampling rate of 12,000. Okay, so when you use the resample function, it becomes just a matter of choosing P and Q. All right, so our goal is to make sure that it exceeds 68K. All right, and we're starting with 8K. So if I did 8 times 9, 8 times 9, 72. All right, if we upsample by 9, and downsample by 1, that would take care of it. We'd have plenty of headroom in our new sampled signal that would allow us to modulate. Okay, and then to modulate, we would just then need to, apply the resample function, generate the appropriate oscillator, and then literally modulate. Okay, so let's go to MATLAB and work on these steps.
Here in MATLAB, from before we had learned to read an audio signal, so we were reading in speech.wave, and we can then plot what that looks like in frequency. So let's run both these. Run the first one, run the second. Here's the plot, and we get what we were expecting to see, that sort of blob shape of the Fourier transform of speech. Okay, so next, we talked about previously in the video the need to resample the function to give us more bandwidth to make room for modulation. So I'm going to call the resampled signal y up because it's upsampled. So we literally type in resample, the original y vector, and then the upsample factor. The upsample factor is 9. So you see, and the downsample factor is 1. So the new sampling rate, I'm calling it fs up, is equal to 9 times the old original sampling rate. Okay. From there, we can plot the spectrogram of the resulting signal. So we'll run that section. And the thing to notice here is the change in the axis, on the frequency axis. Okay, so we see all the way up here, MATLAB is generating a plot. This is, the maximum x limit is 4 times 10 to the 4th. Okay, so it's choosing a scale. MATLAB auto scales this up to 40K. All right, and at 72K, the maximum sampling rate, the maximum frequency that would show up in a 72 kilosample signal is 72 divided by 2, or 36 kilohertz. Okay, and for grins, you can zoom in here and look, and you see we still have the original blob shape from speech showing up between -4 and 4. Resampling simply gave us the headroom to modulate. Okay. All right, so the next thing I need to walk you through is generating an oscillator so that we can do the modulation step. Okay, so in MATLAB, you're going to multiply two signals together. You're going to multiply the upsampled y times the oscillator. So the length of the oscillator and the number of samples of y up have to match. So I start with some code here. N equals 0 up to the length of y up minus 1, right? If I start from 0 and go up to 9, I have 10 samples. All right, so that's what I'm doing there. Then I transpose n so that it has the same shape as y. Y turns out it's a column vector. This will make n a column vector. And then I just make my oscillator. So I'm calling it OSC for oscillator. It's a cosine function. The frequency is 2 pi times 30,000, so it's 30 kilohertz. I multiply by the sample value, and then I divide by the sampling rate to get this in terms of a sampled data signal. Okay, so that'll generate my oscillator. And then modulation is real simple. You just multiply these things point by point together. This little point here is important because otherwise it would be trying to do a matrix multiplication, which in this case wouldn't even be defined in MATLAB. So we're doing this point by point, and what we can do at that point is run everything, and it will pull up the plot of this modulated signal. Okay, so it's doing what we expect. It's hard to see, the oscillator because this is just a big blur of signal here, but this is the original wave, the original speech signal multiplied by the oscillator, and you see the blobs here moved out in frequency. So if I zoomed in on just this part. We have that same kind of Fourier transform blob shape that we did before, but instead of going from minus 4k to 4k, it goes 30k minus 4 in this direction and plus 4 in this direction. Okay, so this is a modulated signal like we would expect to see.